Hello everyone. This is the course Elements of Electrical Engineering. Elements of Electrical Engineering. In this course, various topics are covered, and this course forms the foundation. Here mainly we will be covering the fundamentals and we will be studying the fundamentals, and this forms the foundation course and for various other courses in the higher semesters. Okay, mainly here we will be covering DC circuits. Again in DC we will be covering DC machines. In AC you will be covering AC circuits. We will be studying single phase AC circuits, three phase AC circuits, and various AC machines like alternators, transformers, induction machines, alternators, transformers, and induction machines. Apart from this, here we will be studying both motors and generators, DC motors and DC generators. Apart from this, we will be studying domestic wiring also. Domestic wiring. Okay, here we will be studying about the various types of wiring used in our homes and earthing, types of earthing, pipe earthing, plate earthing, and what is electric shock. What are the precautions to be taken against shock, like this. These are the things we will be covering or studying in this course. So first, what do you mean by electrical circuit or electric circuit? Electric circuit, whether it is DC circuit or AC circuit. Okay, what do you mean by this? So basically an electric circuit is an interconnection of various elements like voltage source, current source, resistors, inductor and capacitors. So you can have a DC circuit or AC circuit. See, DC circuit consists of DC voltage source or current source and resistors, like this. This is a simple DC circuit having a voltage or battery. Okay, you can have any number of resistors connected in various configurations. So it's an interconnection of elements. An electric circuit is an interconnection of various elements like voltage source, current source, resistor, inductor and capacitor. So a DC circuit looks like this. Okay, whereas if you go for AC source, AC circuit, this AC circuit consists of a alternating voltage source. An alternating voltage source is represented like this. It can have a resistor, it can have inductor. Inductor is denoted by L. This is resistor, and it can have a capacitor, C. Okay, this is the AC voltage source. Okay, this is the DC voltage source. Okay, it can be AC generator, something like that. Okay, so these are the examples for DC and AC circuits. See, any electrical device or electrical machine, the performance or behavior of the electrical machine is studied by drawing its equivalent circuit. Okay, it will be represented in the form of circuits. Any machine, okay, the performance or behavior of any machine is studied by drawing its equivalent electric circuit, right? So this is about what is electric circuit. So if you come, basically we have elements. What are the elements means? These elements in electric circuits are broadly classified into two types. Okay, one is called active element. One is called active element. Second one is passive element. Passive element. Active elements are also called source or sources. Passive elements are also called sinks. These active elements, they possess energy of their own. They possess energy of their own. Okay, active elements examples are voltage source, current source, battery, and some other elements. They have energy of their own. Okay, and they deliver it to other elements, mainly passive elements. Okay, active elements have energy of their own. Okay, voltage source has energy of its own, battery has energy of its own. Okay, and they deliver this energy to the passive elements. On the other hand, passive elements or sinks, they do not have energy of their own. Okay, they receive energy from the active elements. Passive elements do not possess energy of their own. They receive energy from the active elements or sources. For example, you can have or resistor does not possess energy of its own. Okay, similarly, inductor does not possess energy. Capacitor does not have energy of its own. They receive energy from the active elements or sources. Okay, they receive energy from the active elements or sources. One more definition: active elements are the elements which change the characteristics of the signal. Which change the, for example, diode. Diode is an example for active element. Okay, if you pass a signal, okay, the signal will be rectified like this. The characteristic of the signal is changed. If you have amplifier, okay, if you pass a weak signal through this, the output of the amplifier, you will get a strengthened signal, strong signal, whose amplitude is increased by many times. Okay, here active amplifiers mainly consist of transistors. Okay, they are also an example for active elements because here the characteristic of the signal is changed. Okay, similarly diode, when you pass half wave rectifier, you will get half rectified wave. Full wave rectifier, you will get full rectified wave. Okay, here the characteristic of the signal is changed. Hence, these elements are classified as active elements. When you pass a signal through an element, if the characteristic of the signal is not changed, then they are classified as passive elements. So, these are the two main types of elements. So, coming to voltage sources. So, this is the voltage source. It has some internal resistance, or you have a load here. Okay, this is called the internal resistance. Okay, so there mainly you have two types. One is practical voltage source and ideal voltage source. An ideal voltage source maintains constant voltage across the load, irrespective of the current delivered by it to the load. Okay, it maintains constant. And ideal, see, for example, see, if you have more current delivered to the load, then there will be more voltage drop across this. Then the voltage available across the load will be reduced. Okay, see, an ideal voltage source maintains constant voltage across the load means what? This drop should be 0 ideally. The drop across that means this internal, when this happens, when this drop will be 0, when the internal resistance is 0, the drop across that will be 0. When this is 0, irrespective of the current flowing through this drop will be 0. Here this voltage will be constant. That is ideal. Okay, here nothing is ideal. Okay, actually in practice, in practical, voltage sources always have some small internal resistance. Okay, smaller the better. For voltage sources, smaller the internal resistance better, because irrespective of the current flowing here, this drop will be less. Here the voltage across the load will be maintained constant. That is, they are the practical voltage sources which possess small internal resistance. Okay, so voltage sources internal resistance is always connected in series with the source. For voltage source, internal resistance is always connected in series with the source. So ideal voltage source means ideal voltage source means R is 0. Okay, if you come into current source, so hope I have made it clear what is ideal voltage source and what is practical voltage source. Coming to current source is represented like this. Okay, this is the current source. For current source, the internal resistance is always connected across the source. Okay, this is the internal resistance, this is the load, okay. An ideal current source delivers constant, okay, it delivers constant current through the load irrespective of the current delivered to the load. Okay, that means, see here, this resistance should be very high. Okay, for ideal current source, this is infinite. Infinite means open circuit. In that case, the current flowing through this resistance will be 0. So the entire current source, the entire current flows through the load. Okay, if this is small, what happens? Most of the source current will flow through this internal resistance. The current flowing through the load will be less. Okay, that is a very poor current source. Okay, that is not desired. Okay, practical current sources have very high resistance. Okay, so in that case, the current flowing through this internal resistance will be less. So most of the current will flow through the load. Okay, an ideal current source delivers constant current through the load. Okay, so most of the current will flow through the load. Okay, so that is not, see, this R S is equal to infinity. Okay, this is the ideal current source. This is not possible in practice. Okay, so practical current source means this value of this RS should be very high. So the current flowing through this will be very less. Most of the current will flow through the load. So this is the definition for a practical current source. An ideal current source is one whose internal resistance is infinite. A practical current source is one whose internal resistance is very high. Okay, these are the definitions for ideal current source and practical current source. Hope it is clear. So we have discussed what are the types of elements. One is active element or sources. Second one is passive elements or sinks. Examples for active elements are voltage source, current source. Example for voltage source is battery. Okay. Similarly, you have examples for passive elements are resistors, inductors and capacitors. They don't possess energy of their own. They receive energy from the active elements or sources. Next, we discussed about voltage source. We have ideal voltage source whose internal resistance is 0. So, practical voltage sources have very small internal resistance. Okay, so current source, you have practical current source and ideal current source. In case of ideal current source, internal resistance is infinite. In case of a practical current source, internal resistance is very high. Okay, so these are the definitions for ideal voltage source and ideal current source.